Hello everyone, my name is Dmitry Chemadanov and I'm glad to present our demo today, which won the first prize on the GENI experiment contest. This demo relates to the public safety area and how existing computer vision applications, such for example tracking or applications for 3D scene reconstruction, can be decomposed into some kind of service chains in order to benefit from existing cloud fog architectures to provide real-time visual situational awareness like that. So you might see the regional scale imagery over some Albuquerque city, and what we're doing, we're using some kind of new SDN/service placement protocol in order to speed up such cloud fog computation and data transferring within cloud fog architecture. So the two setups here showing you basically the case when we're using the core cloud computing with standard IP routing over standard networks, right? In this case, all our data treated equally, and hence we can have congestion on the shortest path. In the second scenario, we are doing SDN, where we now can dynamically find the passes which corresponds to our communication requirements of the applications. Then we also can decouple our functions of the application and place a large part of the application into the core cloud, another part into the fog, such that we can remove some sequential bottlenecks relevant to pre-processing and data transferring. As a result, we can get up to 3 times speed up over traditional core cloud computing with IP networks, which is captured here. So you can see basically the real-time visual situational awareness versus the core cloud computing gives you something like frame-by-frame tracking. Thank you, that's it.
Hi, my name is John Oakley, and I'm here today with our TARN project, which is the Traffic Analysis Resistant Network. So one of the problems we face in today's network is traffic analysis. So imagine you're in a country where the internet is censored and you want to access the New York Times. One of the things that we have to address is how you can do that. So what are your options? You can use a VPN, but then you have to trust the VPN host. You could use Tor, but some countries like China drop all Tor traffic. You could use SSL, which the New York Times does, but other countries like Iran will drop all SSL traffic. So one of the things we wanted to do is we wanted to provide an approach where we could anonymize all the traffic. So our approach is we randomize the destination IP addresses of outgoing traffic, and this allows the users to communicate with different geographic locations from the point of view of the censoring country. So the client sends traffic, which is then anonymized with an OpenFlow switch. And the OpenFlow switch talks with the floodlight controller, which announces different IP prefixes, which makes the destination traffic look like it's targeted to different geographic locations. Now, this decouples the IP prefixes with certain geographic locations. So destination traffic headed for the New York Times may look like it's going to the Netherlands. So this provides an anonymous layer that's transparent to the TCP/IP stack that lets us have anonymous internet traffic. Thank you for your time.
What our demo is about experiences using GENI in the classroom to foster deep learning. And what we call deep learning is the ability for students to enjoy their learning experience, be challenged by it, and also make a difference in the classroom. One way students can make a difference in the classroom is by teaching each other. With that in mind, using GENI in a classroom where you don't have TAs and you're the only instructor provides many challenges. And one way to foster deep learning without having necessarily all the resources to use GENI is to create an environment where students feel safe to fail and also have content that the students can access in an orderly manner and can give automatic feedback to the professor. So for example, in the monitor we have, after we've gone through some PowerPoint slides, maybe explaining delay, a typical question, Ambracia is a student that has been used for GENI and will explain a little bit of what the technology looks like.
Okay, so basically the technology right here, we have a question that displayed. It's more of like an interactive textbook. Instead of doing multiple choice on a paper or on your computer, you can actually use your cellular device to text a number and then text whatever choice it is that you would like. It's very hands-on, and a lot of students are physical learners and visual as well, so this would help with that. There's also another way to see who is logged in, so attendance can be taken. The number at the bottom towards the middle is the number of how many students are registered. You can zoom, you can edit to your preference, whatever you like. You can also stop it, and it will show you it will show you the answers that people have picked, not by who, of course, identity concealed. And then there's also a way for you to highlight and annotate, which is another positive thing about it. Like I said, a lot of students, especially first and second year undergrad, me personally, I'm a hands-on and I'm a physical learner. So here with this interactive textbook, you have the two options. You have one to annotate, basically like Cornell Notes, similar, and you can enter whatever you would like. Like we said, it's a hands-on and physical thing. And then you can also highlight as well.
Additionally, we have created a lab here that's very simple. It's how to use GENI to do a self-signed certificate over a web server. And what you can do is you have step-by-step instructions in the interactive environment, and you can make questions over the material that you have, and that gets automated and that gets graded towards the gradebook without the instructor having to grade each item. And additionally, you can have, for example, different types of questions, where we can see here that Lab 0 can be evaluated not only by asking a question, but asking a student to click over a portion of the question. So here, the answer can be shown as a portion where we're asking what portion of the fill-up line, of the blank lines, are used for the GENI server. You can also look at how many students have answered, and there are other types of questions, typical like selection, multiple selection, but we're trying to create an interactive text that will foster deep learning and use GENI as the main technical support tool to foster the challenges that we need in networking for the classroom.
We're demonstrating an open source test bed for wireless edge research. Right now we've got a open source LTE implementation running. You can see the various connection graphs here. And we actually have right now some cell phones connected to it, and so it's commercial devices attached to the software base station and software core network. We also have tested other configurations where we use a commercial core network or commercial base stations, and with this hardware we can run any of the components. The software itself is based on the Open Air Interface project, and so that includes both client device eNode B for base stations and the full core network. In addition to this physical setup, we have versions of it running on the Orbit testbed, which is open for experimenters to access, and a number of tutorials to implement various parts of this. We also have a GENI image of the core network that you can instantiate and then tunnel into.